Hi students, let's look at this question here, which is on application of differentiation of the O-level syllabus. First, I'm going to do this proficiently. So the diagram shows part of the curve where y is x, k over root x minus 1, which a is a point on the curve. So this is a point on the curve, and k is a positive constant. Given also that y is 25 over 4, is a tangent to the curve at a. So in other words, it touches here. So determine the value of k. The value of k. Great. So now the first thing is to understand that if this is a horizontal line, okay, so you know that the gradient here is 0. Okay, that's the first thing. And also the other thing is also, if you're not too sure, you could just do a quick differentiation of this line equation. When you differentiate the constant, you get 0 as well. So it should tally with what you've learned in lower secondary school and what you've learned now. Okay, so that's one. So determine the value of k. I think is not really an issue. You know that dy dx is equals to 0 here at a. I'm not sure what's the a here, but I know that, I mean, the coordinates of a should be like x comma 25 over 4, because it's actually 25 over 4 here. So what we're going to do is just differentiate this, right? So to differentiate this, I will suggest we just expand this in. So I'm just going to expand this expression here. So x k over root x minus 1. This is kx over root x minus x. All right. Of course, we could use product rule, but I think in this case here is probably easier if we use this form here. So this will be x power 1. This is x above half. Okay. So essentially, if we were to rearrange this will be kx. 1 minus half will be half. Okay. 1 minus half. So let me not skip step here. So y equals to k x half minus x. Okay, great. So this case would be k root x minus x. Right? So just to rearrange it. But of course, if you don't really need to do all these steps if you could see it straight. Okay. The other way is to know that, okay, the other faster way to rearrange it would be, this is what I prefer. This is method 1. Method 2 is this is what I will see. So I know that y is equals to x k over root x minus 1. So I know that y is kx over root x, right? I just distribute it in. Then you, of course, can know that x is actually root x multiplied by root x, right? Then that will be much faster. Actually, you can get it straight, because by cancelling 1, reducing it, it'll be much faster here. So y is equals to k root x minus x. This is much faster by using the rational form, natural form. So now once this is done, we what I could do is just dy dx. So dy dx on both sides, dy dx. Okay, this is x to the power of half, so it's half x minus half, then minus this is minus 1, right? So this will be k over 2 root x minus 1 dy dx. And I know that dy dx is equals to 0. So this is when dy dx equals to 0, we know that k over 2 root x minus 1 equals to 0. Okay, so that's 1. Then what we can do is we just going to substitute it in. Oh, we need to find the value of x, right? So it's 2 root x. 2 root x here. The 1, so k is equals to 2 root x. Okay, now, so this is our dilemma now. We are told to solve for k, but we do not have the value of k there, right? So what we're going to do is actually, we could solve for our value of x by using this function here, okay? So we're going to equate y. Okay, so essentially now we know that k is equals to root 2x, and this is what we should be able to get for our answer. But because we do not, we in order to get the answer, we need to find x, right? So what we're going to do is just solve for a. So sub y equals 25 over 4 into y equals to k root x minus x. Okay, so that I'm just gonna substitute into this form here. So this case here, what we get is 24 over 25 over 4. 25 over 4 equals to k root x minus x. So now we need to solve this expression here. Now there are a few ways of solving this. There's one way. I think we could just you can use substitution if you want to. You can let v equals to root x. I think you could actually solve it, or I think the other way that most students would prefer is just to square both sides after rearranging it. This is 4 here. This is k root x. K root 2. Okay, so what I'm going to do is I just square both sides. Square it and square it. That will give us 25 over 4 square plus 2 25 over 4x plus x square equals to k square x. Okay, there you go. So we're just gonna simplify this. So what we're gonna do is just gonna square this up because this is k square. So I'm just gonna sub this into this k square. So sub 1 into 2. Then this is 25 over 4. I'm just gonna leave it as it is because I'm a bit lazy. So the 25 over 2x plus x squared. Now the reason why I want to substitute that in is because root x over here, this is x. Okay. We then after which we could actually solve the x coordinate. That's the whole idea there. So this would yield so this is a huge number, 25 square over 4 square. I'm gonna leave it as, maybe I just write down 625 over 16 plus 25 over 2x x square. Multiply this is 4x times x. So it'll be 4x square. So this 4x square minus, okay, I'll just leave it as x squared, then minus x squared. Can I just bring everything over 0? Yeah, then we could just solve this, right? So that will be 0 equals to 3x squared minus 25 over 2x minus 625. So let's just do a quick calculator check whether you have roots for this equation here. Likely to have. Okay, because if it doesn't means something is wrong with your equation. So I'm gonna just polynomial, then degree of 2, then I'm gonna put 3 negative 25 over 2, then minus 625 over 16. I pray and hope I get the exactly so good. This is pretty good. Good sign. We have got 25 over 4 and 25 negative 25. So from, okay, we could just quickly do multiply by 16. Okay, of course, yeah, I mean, you could write this down. You can't use calculator technically in the exam, so you just need to show how to do this. So this is, we do it divide by, this is 48, right? So let me check. This is 4. This is, okay, so that will be 0 equals to 12x plus 25. This is 4x minus 25. Yeah, that's it. We could get it. So x is equals to negative 25 over 12, or x equals to 25 over 4. Now, you know that a has only 1 point. So you need to reject 1, right? So a here, we already saw for this a here. Like the x coordinate of a, there's only 1 point here. So this point has to be reject, as x is also reject. as x is bigger than 0. Okay, so there you go. So there you go. So A has a quality of 25/4. 25/4. Alright. So then what we need, determine the value of k. The value of k would then be so k will just be going back to k, 2 root x. So k, hence k equals to 2 root 25/4, which is actually 2 5/2, hence k is 5. Right? So k is 5, not an issue. Then after which we need to decide. Okay, I think the second part is something out of the ordinary that you usually see, but should be okay. Explain the gradient of L. Okay, as x gets large, the curve tends towards the line L. So as x gets large, so meaning to say, let me show you what it means. Okay, on Desmos. So what happened is essentially, if you think about it, if x goes to very large, so this is a point on the curve here, right? So this is a y, and this is the point on the curve. So as it increase very large, the question is, you could see that actually it tends to a slope, right? It looks like a straight line here, right? So let me just switch off y, because that's not part of the thing. What we need is actually the gradient here. So essentially, the tangent. So the tangent is over here. What we want is, as x goes to infinity, becomes very large, what happens is it will tend to a value. And what is the value? Okay, so that is the gradient. The gradient meaning this is dy dx. Okay, dy dx L is -1. Write down the equation. So what we need to do is essentially, for part 2, as x goes to very large, so okay, you don't really need to write all these values down, but dy dx, let's look at dy dx. What is dy dx? dy dx is k 5/2 root x minus 1. So maybe I just put this as part 2. dy dx. So dy dx is equals to 5/2 root x minus 1. 5/2 root x minus 1. Okay, great. So as x goes to very large, okay, I know for a fact that 5/2 root x will go to 0. Okay, this will go to 0. Now the rationale is very simple. You think about it, like if you divide something very, very huge, right, so big, right, it will go to 0, because if you have, okay, I like to use the apple analogy. So if let's say this is an apple here, and if me and you were to share an apple, 2, and each of us will get half, right? If we both of us we get another person in, and we'll get a third each, if we're going to share among 3 people. Now what happens if you share with 5 million people? Okay, you essentially get nothing, right? So if x goes to infinity, this will definitely go to 0. Okay, so essentially what you can say is, since if x becomes very large, okay, 5/2 root x is significantly small. And tends to 0. Okay, this is what we call limits in mathematics. So hence dy dx will become 0 minus 1. Dy dx equals to -1. Okay, so thus the gradient would tend to, gradient of L is 1. So gradient of L is 1. Okay, that's it. Now, then after which, of course, if it tends to infinity, you know that it becomes -1. The problem now is, write down this equation. Okay, what is this equation here? The equation of L is, if m is -1, then the line L would just be y equals to -x, right? So the equation of L, is y equals to negative x. Okay, so that's it's actually just y minus y1 equals to mx minus x1, but because L passes through 0, so this is 0, this is 0, and this is -1. Okay, but if you it's just that's about it. L passes through 0, right? 0 and 0, then this gradient is -1 because we just found it out just now. So that's how you do this question here proficiently. If you have any questions at all, please let us know, and I'll see you in the next question.